let's get a petition going to ban the borehole log. That's something that I'd love to see happen at some point in the future, and I really hope that at some point in my career we see a project where PDF borehole logs are not a key deliverable to the client. It's all done through the data.
Welcome to the Ground Investigation Podcast, a show featuring interviews and insights from leaders in the geotechnical and geo-environmental business world. Join host Michael Taylor as he discusses the ups and downs of running a business in the GI industry, getting geological experts to share their learnings and lessons, as well as their plans for the future, highlighting what they think will improve the ground investigation industry moving forward. Now, here is your host, Michael Taylor.
Welcome everyone, brace yourselves for geotechnical adventure. Our guest today is a true Aussie rock star in the field. Given his free choice of fieldwork projects, our guest would take on slope stability assessments and, curiously, pavement trial pits. But that's not all. Our guest is a recognised leader of adapting digital engineering concepts to work in the ground engineering space, and his current role at Macquarie Geotechnical in Central New South Wales, Australia. He works to identify opportunities where good geodata management and collaboration can significantly improve outcomes on some of the largest infrastructure projects in the country. Our today's episode, we're going to hear about innovation, humanitarian geotechnics, drones, photogrammetry, digital transformation, and I've been told to expect an analogy about rockets. So join us as we unearth the secrets of soils, slopes, and digital marvels with the remarkable Tim Swavley. Tim, welcome to the podcast.
Thank you, Michael. And sorry for the Outback Aussie accent.
We'll forgive this time only. Okay, so you've had an impressive career to date, starting at a graduate level through to becoming an associate and senior geotechnical engineer relatively early on in your career. Can you please share some of the milestones that shaped your professional development in the ground investigation sector?
Yeah, so I went to Sydney University. It's one of the fairly high ranking universities in the Australian higher education market, I guess. And one of the things about Sydney University is it teaches you engineering from first principles. So rather than here's the standards, let's just apply them and get you out the door. I hated it at the time, but I'm really thankful for it now. We went through a lot of first principles and how to think like an engineer, I guess, to quote Mark Rober, although he does it much more sexily than our professors did at uni. So I had a really good, well-grounded education, to use a bit of a pun there. I did a few summer placements in some mines. The mining industry has a lot of money backing it, so I encountered a lot of, leading-edge technology there, both surface and underground. And then I did a little tenure with a rope access contractor. That was pretty cool, abseiling down cliffs with drill rigs and helicopters and things like that. But turns out the contractor life wasn't necessarily for me. And made the jump after about a year out of university to one of the Australians' larger geotechnical consultants, Douglas Partners, and I spent more than a decade there. These days I'm with a much smaller but very nimble consulting firm called Macquarie Geotechnical, as you mentioned before. And we're pretty excited, I guess, to be trying to change the Australian market to some extent to bring more of the UK model of ground investigation contractor to the way we do things in Australia, where it's traditionally been consulting firms who offer the full integrated package. They do the site investigation, they do the analysis and interpretation, they do the design work all under the one roof, whereas we're trying to spin that a little bit differently in our day-to-day actions and getting some good attention from the market.
So you say you kind of emulate the UK way of doing it. Why is that?
There's a few reasons. Some of the feedback we've gotten from our clients is that it's very difficult to maintain a team of good field staff. There's been a bit of feedback that some of the younger people coming through want to spend more time sitting in front of a computer doing numerical analysis, and finding people who have the right skills to be sent out into remote parts of Australia to do field work and come back safely is one of the challenges. And there's a lot of, if you like, overhead or baggage, I guess, to maintain a team of staff who can go out and do a lot of the field work, especially at the moment with the massive spending from governments in Australia on infrastructure. I guess they can be doing a lot more with their team in-house. And I think the digital cliff that everyone's about to drop off is a pretty significant one as well. So we're really trying to take the market by providing highly skilled staff whose field work and the real world is their passion, and also really add value by delivering it with digital capabilities and opportunities that they can't necessarily emulate themselves.
So you mentioned something there in relation to, perhaps graduates or maybe some with some experience not wanting to just be site-based, wanting to kind of see the projects throughout its entirety, the writing reports, etc. And that's something that we experience in the recruitment. Is there's certainly a lot more people who want to see it all the way through. Some people are absolutely happy to be on site all the time, and that's kind of how they are. Others don't want to go to site at all, which can work, but for a lot of companies, they need to have some site experience in order to be able to feed in and add value to the project in the office, I think.
Yeah, definitely. And it's really interesting that finding that balance between having the right field experience and then having the office experience that informs the field experience. But one of the things as well that we're finding is as we become more data centric, and we'll probably touch on that term a bit through our little conversation today, it adds a whole new element to doing field work. You're not just out there preparing a log, you're producing this data set that when you get it right, and you get it right the first time, or with minimal sort of complications, the efficiency and all the things that can come out of you doing your field work well is really a rewarding experience, which I think isn't necessarily something that I encountered as a graduate when your end goal is a neat bit of paper that can go to the typist to be put into a GINT log.
Yeah. So you said that you've gone from a leading national geotechnical consultant firm where you advanced to the point where you had more seniority and you were doing kind of more specialized work. So why have you swapped your shirt and tie for a high-vis and hard hat, given that your current role has much more site work?
Yeah, well, I worked for Douglas Partners for 11 years or thereabouts. A great team at Douglas Partners, some amazing engineering maturity and very well-established practice, and I'm very thankful for the time that I had there to learn the trade, I think, off some really well-educated and engineering leaders in our local practice. But life events sort of came my way and ended up requiring my family to move out to central west New South Wales, away from where they have any operations. And that's where I found Macquarie, who I currently work for, is headquartered, and turns out that we have some similar opinions on what the industry could be, particularly in terms of how site investigation work can be done, how the field work can be done, and the results that can be produced. And overall, I'm much more comfortable in high-vis out in the paddock than I am sitting in an office just coordinating other people who get to go out and have the fun. So here I get the best of both worlds, a bit of office time, plenty of site time doing field work and training others. And one of the other things I think why I really focus on the data capture and the fieldwork side of things is in my experiences where I've done design and analysis work from a geotech perspective, just taking information from PDF logs and typing it into a spreadsheet frustrates me and strikes me as a really archaic way to do things. But I've not found any other providers who are able to deliver geotechnical data really well. And so that's what we're focusing on at MacGeo, being the first ones in the local context. I'm not sure what it's like over in the UK and other parts of the world, but really being the experts who can produce data that is of high quality, really accurate, really reliable, and is able to then enable all sorts of other downstream tasks.
Sure. Okay, so you mentioned about how you'd kind of like the industry to be. So perhaps carrying over some of your experience and some things that you would like to change or see changed in the future. What could you just give us a little bit of detail on that, please?
Yeah, I'd love to see Excel spreadsheets more or less banned from our industry. There's so much opportunity that comes from moving away from analysis, which is done just in a spreadsheet, which is a page, a handful of logs given to a graduate and said, go and type this in and make 1,000 copies of a spreadsheet. I'd love to see more parametric design being brought in, where we set up these models right at the very start, and as the information is produced from the site investigation consultant, as it's interpreted via the various different design actors, it carries through the parametric, and what we're building on, and we'll probably explore this a bit later in the conversation, is this concept of design in real time. That's where I'd love to see the industry going. and data-centric practice. And I heard this from Roger Chandler, I think of Bentley fame initially, and I'm going to steal it. But he said, let's get a petition going to ban the borehole log. That's something that I'd love to see happen at some point in future, and I really hope that at some point in my career we see a project where PDF borehole logs are not a key deliverable to the client. It's all done through the data.
Sure. I would say here in the UK, sometimes these things are quite slow on the uptake of the companies. Is it similar in Australia?
Absolutely. I mean, you guys have been using AGS, the AGS data format for decades, and where we've only just in the last few years done a national organisation agnostic localization of that data format to fit within our Australian standards for practice. So we're the decades behind in terms of uptake, and digital literacy amongst data users is a key hurdle as well that the industry has to really overcome. And it's exciting to see some tools like ChatGPT becoming a reality, not because they can do the work for us, but because of how they can assist us in our work, which will also probably be a topic of conversation a bit further as we go along.
Yeah, definitely. ChatGPT and various other formats similar are, yeah, you can use it as an assistant. It's fantastic. You can't just plug it in and give you out because it still creates a fair few errors. But if you apply your human brain to it, then it's extremely useful.
Yeah, definitely. One of the best applications that I've seen for it in our industry, this was done by Lewis at Boredom. He's building a GDMS platform out of the US, I believe, is using that generative AI to actually bridge that digital literacy gap. So for people who can't necessarily write code and queries to be able to access a data set, you can put it into this engine that he's got in a natural language model, and it'll spit back the code that it can pretty much copy and paste directly into the query prompt and come up with tables and lists of all sorts of information that would otherwise require quite a bit of experience with using database systems.
When you find someone and they are computer literate to that degree, do you find that as a particular person? Do you find there's much of a crossover between someone who's kind of doing the project management, getting their hands dirty on site, and then someone can go back to the office and actually get into that level of computer literacy?
Yeah, I don't think that there's a divide necessarily between people who enjoy fieldwork and people who enjoy time in the office. I think from some of the staff that we've seen come through our doors in more recent years, they're well educated. At least over here in Australia, our school and university curriculums are catching up to some degree. So many of the recent hires we've had have got some experience with writing basic scripts and computational thinking. And so, yeah, they're enjoying the field side of things, and they're bringing it back to the office. And they're doing this sort of iterative thing, right, which is very much the computational thinking and the sort of engineering progress life cycle of, here's an idea, if I collect my information this way or we do this in the field, when we come back to the office, it can adjust how we process our information. We can do that faster, and then the next time around we'll make a little tweak to what we've done before, and they're doing this sort of cycle where they're continually improving. So I think on the whole, the office versus field orientation divide isn't that significant with some of our staff at the moment. When it comes to dealing with clients, we've got pretty significant challenges with, I think, digital literacy, where it comes from the seniority that you need to be able to run an engineering project and be the person who signs on the dotted line at the end of the project to say this project will perform according to the specification and our company's insurance is at stake. That person with 30 or more years experience, they learnt their practice and they've practiced their practice over the last 30 years without computational thinking necessarily being a thing, without the idea of algorithms and algorithmic processing. And so to come up with this idea of, hey, a computer could do that instead of a graduate, but I need to change the way that I've been doing things for the last 30 years, I think that's a much bigger hurdle than necessarily the personality types that we're finding.
Yeah, it would take a good while, I think, for almost like a paradigm shift of thinking, really, for that to be put in place and to start to become normalized.
Yeah, I think it's a little more than a paradigm shift. I don't know, I kind of liken it to my oldest son, Archie. He's 9 years old. He's learning these computational concepts in school now. He's in third grade. And I kind of think that he's got a greater appreciation of what could be done than many of our engineering leaders. And so really it's a little more than changing thinking. It's really they have to completely reinvent their craft to be able to work in that with that digital mentality and taking advantage of it. And one of the challenges I think is that if someone's paying their bill, if they're getting $300, $400 an hour to do things the old-fashioned way, and the industry's not complaining and they're happily paying for it, well, where's the motivation to spend 6 months retraining and all the downtime and challenges of completely reinventing your workflows? There's no motivation there.
In terms of your fieldwork experience, obviously you've worked in various locations, around Australia. Where exactly kind of have you worked, and have any of those locations had any unique challenges?
Yeah, so I've primarily done all my professional work onshore here in Australia. I've done one or two projects in Papua New Guinea, sort of to the north of the main chunk of Australia. But if you imagine, I'll say some place names, but they probably won't mean a lot to your audience. But if you imagine a map of Australia, the shape there, if you superimpose a clock on that map, I've been lucky enough to work on projects from probably about where the 10-hour mark would be, right the way around through 12 o'clock, 1, 2, 3, all the way down to probably about where the 5-hour mark would be. So the northern parts of Australia and right up and down the eastern states. When I was at DP, I was based out of Sydney, Townsville, which is up in North Queensland, and Newcastle offices for a good stint of time in each one of those.
So you mentioned Papua New Guinea. How was it like working there?
Oh, that was phenomenal. Just the environment, the steep hills, the tropical climate. It was amazing getting to see some of the villages and the local people that we worked with and helped guide us around. On this particular job, we were in the sort of northwest part of Papua New Guinea, and we had 6 helicopters operating on site, sort of ferrying people and equipment and drill rigs and core boxes and things around the place. It was just so hard to come back home to and then sort of sit in the Hilux ute and drive around from site to site. It was a phenomenal experience.
So were you welcomed by the local? Was the project a welcome project for the local population?
Yeah, it was. We have had some projects where there have been some challenges and infighting, I guess, between some of the different tribes that may or may not be involved or feel like they're not necessarily getting equivalent benefit out of the projects. But in this case, it was an exploration for a fairly large mine, a feasibility study, and that had teams that had gone in over years and years and had sort of really established relationships with the various impact villages and people within the footprint. So yeah, it was a really pleasant experience on the whole. But working cross-culturally, we were working with the people from the villages, so they'd come and stay in the camp. We'd share the dining room and a whole lot of the facilities together. So yeah, the people we were working with had only been sort of interacting with white fellas coming into the jungle for only a few years. So that was really great to share some of those experiences with them.
That sounds fascinating. So you kind of bonded really over eating food around the dining room table, which is always a good way to do that.
Yeah, and the cooking team as well, I might add, was from those villages. So we got a great taste of much of the local cuisine as well.
What was the local cuisine? What was your kind of favourite?
A lot of rice, and it was it's a lot of meat just cooked straight over the fire where it was available. Coca-Cola was really, really popular. And one of the really interesting things that we noticed was, we're used to having supermarkets and my wife and I, we go and plan out our week's meals for sort of what we might want, and we can always get what we want when we need it. But these guys, when the mine site never went ahead, and so they've gone back to sort of their hunter-gatherer sort of lifestyle, and so their metabolism was very different to what we're used to. And so we'd get what was supposed to be a month's worth of flour flown in one day, and then we'd eat cake for 2 days, and then there'd be no flour left for the next month. So we'd be back to rice and whatever else they were mustering up. So that was pretty fun.
I suppose we're quite used to have very regular eating, really 3 meals a day, and there's never any failure of that. But you need to eat what you can eat when you can eat it, in what's in season, and all the rest of it, I suppose, over there. It's funny you mentioned Coca-Cola. You do see Coca-Cola in every little nook and cranny of the world. So going back to your experience in Australia, are there any particular unique challenges that you've faced, in Australia itself?
Yeah. So I've worked out of yeah, Sydney metropolitan, big smoke sort of area where I was doing work in the CBD, rock mechanics, basement excavations, and deep piles and things in the Sydney CBD to North Queensland, which is about 2,500 kilometres north of Sydney. If you know the east coast at all, Brisbane is about 1,000 kilometres, I think, to the north of Sydney, and then yeah, we're another 1,400 kilometres north of Brisbane. So Brisbane is better friends in some ways than Sydney, even though Townsville's in the same state of Queensland as Brisbane. So it's a long way north, and Northern Australia, I think, was probably one of the key points in my career. Being that far north, you have to diversify your skills a lot, and working up there, there's a lot of mining and defence infrastructure, and so with a smaller team, you're far away from everything, but you have a lot of the same sorts of challenges as you would in metropolitan Sydney in terms of the things that people are trying to build. So that was really good, but just the environment in Northern Australia is pretty difficult as well. It does get tropical, it does get really hot. We had a few pavement projects where you'd jump back in the truck between test locations, and the temperature on the dashboard there was showing that it was 50 odd degrees, and we worked out that it was actually probably more than that. That's just as high as the gauge would go. They never thought that they should make it to go any higher than that. And on a good day's field work out there, I drink at least 7 litres of water while I'm out doing the field work, and then we'd probably call it a day and come back and drink a whole lot more back at the accommodation as well overnight. And to add to the climate, everything else up there is trying to kill you as well. There's lots of stories I could probably tell you about encountering crocs and snakes and spiders and all sorts of things in the field. I had a run-in with what's called the gympie tree, which is the world's most venomous plant. So as a general rule, if you're travelling in North Queensland, the moment you step off the Bruce Highway, everything's trying to kill you. We also operated day to day up there, about a 900 kilometre radius from our office. So yeah, it was perfectly normal to wake up in the morning, turn up at work, get given an 800 kilometre drive to go and do an hour or two's worth of construction inspections, and then turn around and come all the way back.
It's very extreme, isn't it? So you're saying it's just kind of the northern Queensland area that everything's trying to kill you?
No, I think Northern Australia is particularly harsh, east to west. Done some jobs in WA as well. Crocodiles are a big thing right around the top. Darwin in particular. There was a story that was in our news last week about a fella in the top end, so that's Darwin, Northern Territory, a farmer who was taken by a crocodile, and he...
Finding the right staff is hard, really hard. At GI Rec Limited, we understand the ground investigation market inside out and can make all the difference to your recruitment woes. You need to concentrate on running the business, which is very difficult to do without the correct number of qualified staff. We can help you get your time back and lower your stress levels. We only work with talented, referenced, and often entirely exclusive candidates across the ground engineering sector. Wouldn't that be nice? It's not a dream, it's a reality for many of our happy customers. Get in touch with the team now to book a call. Just email info@girec.co.uk to book a call, or click the link in the show notes now.
Fought back and bit the crocodile's eyelid, and the crocodile let him go, and he walked away to tell the story. And so yeah, that's your day-to-day job site sometimes, working with those hazards. So yeah, right across the top end there, you got cyclones as well is another one. So yeah, you can't really escape it. Anywhere sort of north of the Tropic of Capricorn, you'll hit it.
In terms of a risk assessment, how does that happen? The work in which you would carry out can be dangerous enough, but when you add the local wildlife, etc., and the dehydration and tropical climate, how do you do that?
For everything that we say on paperwork, you still have to have experience and a bit of sensibility about you to actually be in that moment and think, hang on a second, I do actually need to stop and drink. This is not the sort of things that I've done before. And you start training yourself for it. So on some of those days where we're drinking a lot of water, the first thing you do before you even leave the yard in the morning, you've probably already drunk a litre or two to make sure you're fully hydrated. So there's a lot to learning in that, and you learn that just going about daily life as well. Not necessarily your working life isn't the only place that you're learning that. Definitely following the safe work method statements, having an awareness and watching out for your mates as well with the heat. We did some pretty funny things as well. I've got some photos somewhere of me doing DCPs for a pipeline hanging out of a man cage on a crane because of the crocodile risk in this particular area. The only way we could engineer out the hazard was to lift us in with a crane and drop us down sitting right above the water and testing through the bottom of the cage. Yeah, croc-proof fences on barges when we're out doing overwater drilling as well. It takes additional consideration, and particularly with the way the company was structured at the time, a lot of the swims were coming out of the central Sydney sort of offices. So we'd had some standard items that we'd sort of throw in there every time, modify them.
That's fascinating. Very different to the UK in terms of ground investigations, which I expected anyway. But hearing it, from yourself in terms of how you mitigate and everything, it's amazing.
Yeah, that excites me, right? That additional challenge. I've done a bit of work underground as well, and just having to go into this sort of context where you need to follow the swims and you need to really appreciate the hazards, or you can really come unstuck. That's a bit of an additional thrill that I really enjoy about this job. So much more fun and excitement for me than just going to a construction site in Sydney and looking down a couple of pile holes.
I kind of appreciate that side. So could you discuss any notable projects or achievements that you're particularly proud of or has been particularly significant in your geotechnical career so far?
Most favourite job, I think, was for a large prawn farm going in up in the top end. And so this is where you had all those risks. So if you imagine a map of Australia, we're sort of in the vicinity of the Western Australian Northern Territory border. This site was pretty remote. We were a few hundred kilometres away from the nearest town, which most of you probably wouldn't even call a town. I think it only had a couple of thousand people in there. So we were able to fly into there, but then we're still driving a few hours out of there and pushing CPTs. And there was, as we got closer and closer to the river and the intake area, the ground was getting softer and softer, and so we got to the point where we couldn't bring any of our equipment any further. It was just sinking into the mud too much. So as we went back and we were working in other areas of the site, they came out and started doing some helicopter mustering, and we thought, hang on a second, we got all these helicopters here on site. I wonder if we can helicopter the gear in. So we didn't get to do it on that occasion, but that's how we came up with the silly idea, and we worked over it over the next couple of months till having that information was critical, and we went back with a helicopter, a Squirrel something or other, quite a big machine, and spent a few days flying equipment in and around the site to do these CPTs, and we would pump water and probably a few baby crocodiles in from the river into the ballast tanks, and that would hold down the CPT equipment while we did the work. And I led the whole project, and like I was just saying about work with extra hazards and extra challenges and logistics, it was my time to shine. There was really challenging logistics, had to interpret ground conditions on the fly. We had a few equipment malfunctions, which I had foreseen, or at least thought it could happen, or planned to back up and was able to fix the equipment. There's a photo somewhere as well with me up to my ankles in mud, probably deeper than that in mud, with a generator and a soldering iron, soldering back together the CPT cable. But in the end, we got a whole extra test location, more than we were planning for. We got the information, and we did a great job, and that was great. I really enjoyed that project. We did another couple after that. It worked so well where, just flying with a helicopter was probably one of the easier ways to overcome the environmental challenges that we were facing. There are a couple of other key projects that I think helped define my professional development in time, and they weren't actually work jobs. There were a couple of humanitarian projects that I got involved with, again up in Papua to the north, and a couple in Indonesia, sort of to the northeast of Australia.
So how did you become involved in that, and what did you actually do? It's
a really interesting area to work in. From the outset of my career, I guess my religious beliefs have encouraged me to sort of think about doing a bit of a side hustle, I guess, in some pro bono work or volunteer humanitarian type work with the professional skills that I've built over the years. And so from quite early on, I sort of thinking along those lines. I was doing a lot of deep basements, rock mechanics, and that sort of stuff. And there's not much of a market for deep basements for refugee camps or that sort of infrastructure in the developing world. So I sort of thought about the breadth of the sorts of projects and what you can do with your skills as a geotechnical engineer / engineering geologist, and slope stability was one area that I sort of thought might be useful, particularly landslide hazard and management. And so yeah, I did a trip to West Papua and West Timor. West Timor was actually the first one. I've said them backwards. There's a mission organisation working over there who were generally looking at the challenges that were obstructing development of the community. So water, health, sanitation, some of the typical ones. And through a few connections, they mentioned that landslides, or longsor, I believe it is in Indonesian, were a key challenge, and they had absolutely no idea how to understand what causes these things, where do they happen, what do we do when they happen, can we avoid them, how can we protect human life in that sort of context. So I was probably a bit greener than I should have been going into that scenario, but it was pretty good to get in there and shoulder to shoulder and go around and visit a few different communities. So I didn't the benefit was probably more for me, I think, in that particular experience than it was for the people that we were visiting. We didn't have the resources to necessarily do anything, but one of the biggest moments over there was, or one of the biggest realizations, I guess, is the cross-cultural sort of context, which we have touched on a couple of bit. We visited one family who had a little house, a single room house with 4 generations of the same family living in it. They're subsistence farmers, so they're growing stuff on this, probably 18 to 20 degree slope was their farm area that they were cultivating. And there was a quarry that someone had put in directly up slope from them. And over time, not that long actually, but since they'd done a bit of recent excavation, a whole lot of water was able to collect in the quarry, and it was flowing down through the fissures in the rock and creating a spring point on their land, which at first they thought was great. Here's a great water source, but it saturated the slope and led to a landslip, the crest of which, when I got there, was probably about 10 meters across the breadth of it, but the top scarp was about 200 millimeters away from the footings of the house, one side wall of the house. And so when you turn up, they say, is this safe? Can we keep living here? If I applied Australian standards, you'd say, no way, get out of there right away. But when you think about the context that you're in, the Australian standards don't necessarily apply. We've got a lot of wealth over here, and we legislate out things from an engineering perspective that, I guess from a planning perspective as well, would just be an annoyance, right? Yes, your house will crack, so we're not going to let you do that because you'll complain about it, and it's not necessarily a structural risk, but we engineer things out from that perspective. But to stand there with these people in their one-room house, if you say, no, it's not safe to live here, you're effectively taking away the wealth and savings of 4 generations of that family who are living in that house. But on the flip side, if you say, yeah, it's fine to keep living here, they could wake up the next day at the bottom of the gully, buried in mud and unable to get out. So very, very challenging sort of situation. This is where I say I was a bit green, right? Because the Australian standards, that's all well above the level of where they develop the standards. So it was great exposure to think practically, to think from first principles. And like I said, I learned a lot from that perspective. I couldn't necessarily deliver much.
Okay, so I think everyone's probably wondering then, so what happens with that house there?
Yeah, so I think they managed to get in touch with the quarry owner, and he said, oh yeah, you can use some of the rock from his quarry that was just stockpiled there. So we were able to get some fairly large cobbles and some a crew together with a wheelbarrow. We had zero budget, right? I'd been married for less than a year, I think, at the time. The team who were working with the NGO had been established there for less than a year, so we had a little bit of money, but really nothing to work with. We had no resources in terms of drill rigs or even geological maps in order to do anything that you would consider GI. So the most immediate thing we did is we used some of the rock that we could get our hands on from that quarry to backfill up against the scarp to sort of provide a little bit of confinement. we went down to one of the stores. We were able to get sort of like a marine carpet type product that we used as a geofab as well to stop a bit of fines migration in the short term. And that actually stood up for quite a few years. And one of the key things we said is don't put a retaining wall here because you'll just trap the water pressure. But the last photos I saw of the site when I've checked in is they have gone and put a retaining wall in. So potentially there's an opportunity for a bit more education there. But one of the key things that we could do as well after those immediate responses was to talk about risk. And we did this in a couple of different sites that we went to, saying there's no budget here for us to do the ground investigation to come up with a quantifiable or any sort of risk assessment really in terms of the likelihood. So education was one of the key things, talking to people about what the signs are of hazards, of the ground movement, tension cracking, changes in their structures and things like that, and awareness. They were some of the key things. There's a few resources out there, which maybe I'll grab for you to chuck in the description for your podcast of that have been produced by different NGOs that talk about different community strategies to managing risk. So, for example, we actually went to one village where they said, is there any point us remaining in this village? Should we just over time, should we encourage our younger generations to move away? And us older people will die here, but we won't try and pass on our land and our assets, if you like, to our next generation. So effectively, we're not now taking the wealth of one family and 4 generations. It's an entire village that we're looking at. But there are some strategies in literature where they talk about doing a bit more of a study as a community, recognizing the highest vulnerability, and then the community can collectively contribute to say, okay, well, let's take this area where people are living that is susceptible to landslides. Let's turn that into more of a co-farming sort of area. So it's only really there's only people there during the day. When there's adverse weather conditions, people don't have to go there. People aren't living there. And in exchange for that, finding other areas within the village for people to live. So there's some pretty practical ways there that they can live with the hazards rather than just engineering them out, which is sort of what we do over here in Australia.
Very different to what you'd be used to in Australia or what would be used to in the United Kingdom. It must have a good feedback, in a sense, for yourself to actually be part of something like that and to have such a big impact on someone's lives. Okay, so earlier on you mentioned about drones, which are very popular here in the UK, are certainly becoming more popular at the moment. How do you kind of use drones over there with MacGeo, and what kind of value do you feel that they offer the geotech consultancies?
A lot of the digital tools that I use these days, and drones is a key one, have actually come out of those experiences working in the humanitarian context. Because over there, you don't have as well, so I spoke about drill rigs and just doing an investigation, but you don't even have access to the survey resources that you'd necessarily have here. You don't even have access to your geomaps. There's no principal in the room next door you can go and talk to who's been dealing with that geology and that setting for the last 30 years either. So, yeah, you're thinking on your feet. Yeah. And drones, and so those experiences forced me to be more resourceful to get the job done. And I found several digital tools that emerging or becoming more mature, like drones are, that I was able to achieve the same sorts of outcomes to the quality for that style of project, right? Not necessarily building Sydney Central Station, but we could get equivalent quality data out in the middle of West Papua. And so that was one of the things that kicked me over to learning about drones and photogrammetry and alternative ways to gather information about sites when you don't have those resources that you just sort of take for granted. So in it, MacGeo, we're using drones for site surveys, more or less much in the traditional sort of approaches. So we put it up in the air, we take a bunch of RGB still photos and put it through a photogrammetry engine that gives us a 3D model of the site, which for slope stability type survey and appreciating the setting of a project is really, really valuable information. So we can draw from the data, we can draw cross sections, we get higher resolution of her photos that are really helpful for digitizing information mapped in the field and getting it more accurate from a spatial / survey perspective. We get 3D models, photorealistic models from the photogrammetry perspective, and they allow us to potentially minimise the number of times we go to site, because you can do your initial walk over and then note that there are hazards, but then characterise and measure them up based off this visual model back in the office, without having to do multiple site visits to discover that we missed a particular dimension.
In terms of cost, how does the cost of a drone compare to hiring a surveyor?
It's that much cheaper that I've never actually had the opportunity to hire a surveyor on a project. I've been able to produce a lot of the data that I've needed myself, particularly in that North Queensland sort of context, where if I'm driving 800 kilometres to get to site and a surveyor has to come along too just to get a couple of levels of where I've done DCPs or a hand auger, you're paying 16 hours worth of someone's charge out time otherwise if they have to bring out a surveyor. So to throw a drone up and get that same information in the space of about 20 minutes on site, it's really difficult to compare. And then compared to your traditional methods where you'd go around with a reflector and a little Trimble screen type collector device and a jigger set up somewhere, you can take 1 point every minute or two, whereas in a 20-minute flight with a drone, we can cover several hectares and get a few million survey quality pickups of the ground surface.
You mentioned about photogrammetry there as being one of the components. I've seen some of the pictures that you've had up on LinkedIn. I've also had a look at the website, and there's a few pictures up on MacGeo's website in relation to photogrammetry, some of the test pits or trial pits, as we call here, how much you can zoom in. They can have a tremendous amount of data there. So I wonder if you could just tell us a little bit more about photogrammetry in general and how you utilize it there.
Yeah, so the general photogrammetry process, right? So that when it comes to drone surveys, there's a couple of different techniques that people can use. One is LiDAR, which is light distance and ranging. So you have an active light source on the drone and it fires out a little laser beam and measures the reflections as they come back. That's LiDAR. That's pretty good because you're firing a laser beam from that point. You can penetrate between foliage and vegetation and leaves and that sort of thing. With photogrammetry, we're just using a camera, nothing more than camera off the shelf that you could buy from a consumer electronics store. Some of the models that you've just made reference to, Michael, were actually shot on my old iPhone 7, and we're getting sub-millimeter resolution in those models. But they do work with reflected light, passive light. So if you can imagine when you do get overlapping vegetations and things, because of how the light scatters as it reflects off, you can't sort of get detail in underneath some of those sorts of features. So there are limitations to it. But the general way it works is you take photos from multiple different perspectives of the same object or the same site, same scene, and then the software uses algorithms to pick out like features. And so it says in this photo, this feature is, you probably can't see my hands on the podcast, but it's 100 pixels long, and on this other one I've recognized it and it's 50 pixels long and it's got an angle of this, whereas the other one has a different angle. And so just through picking out key points and features like that, throwing some trigonometry at it, you can work out the perspective of how the two images were taken, where they were taken from. And if you do that as an iterative process millions of times across several images, you can build this 3D representation of what has been in the images. If you're familiar with The Matrix, was that a late 90s film? There's that scene there, Bullet Time from The Matrix, where is it Trinity jumps up in the air and does that crazy move. That's probably one of the most popular applications of photogrammetry, where they actually had 100 cameras or thereabouts set up on this sort of circle jig right the way around it, and they all took photos at the same time. That allowed them to stop time and do this orbit around Trinity in the air. Exactly the same thing that we're doing, except rather than 100 cameras, we've got one camera and we just move it. So the traditional approach that many of your listeners would be familiar with is having that sort of a system mounted on a drone. You can fly around above all sorts of things on the ground and take those photos, but we've adapted that concept to take photos of much more close-up features. So we are dropping camera gear, doing terrestrial photogrammetry, so it's not based on a UAV flying above the ground. It's a camera on a selfie stick effectively. And we drop that down into test pits, or we take capture imagery of rock core on the logging table as soon as it's come out of the splits, when it's been blown out of the barrel. So it's not been handled, it's not been fractured through handling anywhere near as much as when you take your normal core photos. And yeah, we can get many pixels per millimeter in the level of details that we've got there. Often we have more detail than we can handle, and that slows the overall system down, and we actually have to downsample our resolution to allow it to be a bit more usable on the hardware, the computing hardware that we have today.
So what kind of value does it add to projects?
Yeah, so a 3D model of a test pit, yippee, right? They're nice to look at, but I have to log into a website and look at it and pan around it.
Yep.
So they're cool, they're really fun, but do they actually help us get towards our goal of building a highway that's not going to crack up in a couple of years? We've found a few different ways that we can extract value from these 3D models. One is that, yes, we do have the 3D model. It is pretty to look at. With highways, they're particularly useful. We're doing a lot of work at the moment where we're excavating through an existing formation and existing pavements. And if you think about it, a test pit log is really a one-dimensional representation of what we've encountered in the ground. And so if you've got a long, a longitudinal sort of aspect to your test pit, we do some where we sort of start at the center of the lane, go out through the outer wheel path, through the shoulder and down the embankment. So a lot can change in that sort of area. And so you either do 5 test pit logs and then sort of have to try and communicate how they all fitted up, or do a CAD drawing, or note the offset from the center line of each one, which is, it works, right? But it's not that intuitive. Whereas with these 3D models, you capture all that detail and you can see that someone's come along at some point and done a repair with a profiler right the way along the edge, and then it's been widened as well. So you can see so much more of the history in this 3D model. Even your old-fashioned 2D photos sort of allow you to do that, but you're never really sure where the photo was taken. And you also get a whole lot of lens deformation as well that throws the scale out as you get further and further away from the images. So all that's taken out with the photogrammetry reality models. So that can be a key value, but it is very interactive. What we've started doing is, when you build this 3D model using software, we can define an offset plane, if you like, from a feature in the model. So you think of the sidewall of the test pit. We define an offset plane that is set back from that, and then we reproduce that sidewall of the test pit by taking each pixel and reprojecting it as though it were perpendicular to this plane that we've defined. What that allows us to do is produce an image of the sidewall of the test pit that is uniform scale in all directions, and we've redeveloped our log templates to show that image stuck smack in the middle, and then we still have the stratigraphy and the layer and material descriptions on one side and the samples on another side, but they actually have call-outs that point to that specific element that we're talking about in this uniform scale image, from ground surface to the very bottom of the trial pit, smack in the center of the log. So it really helps convey so much more detail than is done traditionally. And it also means that our logging has to be significantly more accurate. So because you can see this thing to sub-millimeter level sort of detail, the old standard of, plus or minus 100 mil doesn't quite cut it anymore. So once we've done our test bit, we actually have to stop and go, okay, we've got all these recordings. Let's actually make sure that the depths are actually consistent. So we're checking our work in the field, because we know that is going to be way more verifiable than the traditional approach of, let's just take a photo from the side of this pit looking down into it, and you can't really tell what's going on, what depths anything's at, and you can only sort of guess layer transitions to within a couple of 100 mil. You asked as well about if it's easy to introduce the products. No, is the short answer. I've had plenty of people sort of come up to me at conferences and say, hey, we saw that and we tried to do it, but we couldn't make it work. Have you got any tips? Photogrammetry is more as much an art as it is science. There's all sorts of variables that come through between hardware and software, different configurations, different algorithms. And so there's dozens and dozens of different settings in the software, different ways to use the technology that mean it's very difficult to achieve at first time. And actually, to go back to that humanitarian context of how it inspired me, I actually started practicing learning photogrammetry using terrestrial methods before I actually had the company resources to go out and get a drone and start doing it that way. So I learnt the craft with cameras on a pole. or learning from other humanitarian resources and activities where they put cameras on kites or balloons. I wasn't going to take a drone over and start flying that around in different parts of Indonesia. Just didn't necessarily know what the rules were, but no one really seemed to have a concern with walking around with a camera on a pole. And so that's how I learnt the craft, and a lot of practice. I've done hundreds and hundreds of models purely for the passion. So we go on our family holidays. I get the kids to build a sandcastle, and they don't take a photo back to school with them for news or show and tell. They take a 3D model, or they take a QR code that will print it out that they can scan on the everyone's little iPads, and then they have a 3D model of their sandcastle. And when I remember it was my son's 5th or 6th birthday, I think, we're testing something. I can't remember exactly what I was trying to work out, but we made his birthday cake, and I built a model of the birthday cake, a photogrammetry model of the cake, and I put control points in before we cut the cake. And then we had some cake, and then when they were off playing or doing whatever else, I built another model, and that was my test environment. That's how I learned to build models that take into account changes over time, and then doing point cloud analysis to then highlight areas where there's been more change, right? So you think about this in the sort of slope stability context. If I can build a model of a rock face, and I can do that, and then come back in 5 years and build another model, and then I can run a software process that can compare millions and millions of points to go, well, actually, there's been significant change in the points in this area. It could be a wedge failure developing, or that could highlight the area where a lot of the debris that have been coming down have been coming from, because there's been significant changes in the model. And so, that's my son's 5th or 6th birthday cake is where I sort of first learnt the techniques to do these sorts of things, and then carry it across into the real world. You can't talk about photogrammetry in this sort of context without sort of its flow over to GIS, right? GIS systems are how you access a lot of this information. And tomorrow's actually, the day after we're recording this, is World GIS Day. And so I've got a couple of things planned to try and go into the school, right? So just them going to school with 3D models of their sandcastles from their holidays isn't good enough. I'm going to actually go in there and embarrass them in front of their class as well.
You have a passion. You're not just in the industry. It's not just what you do for a job, really. Whether you're on holiday, whether it's your child's birthday cake, you're always kind of thinking in making steps towards getting better, really.
It's getting better. It's understanding the capabilities of the software. And again, it became a passion because I was trying to work it out, because I thought it would be possible, or I saw examples on the internet or other people in that humanitarian world who thought it would be possible. But trying to work out how to do it myself with no resources. So that's what really led to just trying to work out how to solve that problem myself. Many late nights of trying to figure out a model, and then you set it off, leave it running, and you're getting up with young kids at 2 or 3 o'clock in the morning anyway. So you're feeding them or giving them a cuddle and checking in on your photogrammetry model. The motivation on the whole has been to actually produce this product that I knew should have been possible, and it's trickled down from there. And the latest things that we're trying at the moment is we're doing so going into the actual paid work context, right? Not just me being an enthusiast in my spare time, is to try and capture high resolution photogrammetry models of roads under tree canopies. So that opens up the opportunity to run AI processing across an ortho photo of a pavement to look for cracking and picking up on all sorts of different defects in a road pavement. But we can't necessarily capture that information with drones because there's a tree canopy. We can't also shut down the road because it's a state level asset. They don't really want to close it down. So we have to find out, hey, let's go back to the first principles of how this software works, how the capture works, how it processes it, how it builds this model, and let's try a few different experimental things and see if we can capture it off the back of a ute at or pretty close to the traffic speed without interrupting it. So I think that's the cutting edge, I guess, where we're working on at the moment, using this very simple, very basic off-the-shelf technology.
In terms of future applications, what can you foresee for future applications to help the industry?
I think our ability to produce models is pretty mature. If not just us, the software in itself. The first time I actually encountered photogrammetry was nearly 20 odd years ago in mines, taking photos of a high wall. In those days, you used to actually have to put a mark with paint on the ground and get the surveyors to come and do a survey pickup of that, and then pick some features in the photos and get them to shoot that with their theodolite and give you points in the photos. And so to build one model of, I don't know, maybe 100 square meters would take probably a whole day, whereas now it's almost entirely automated through the software. So the software tools have really developed. I think where we need to go in the future with these sorts of things is people who can receive that data from us, or the people actually producing that data. So our model is we do the field work and we provide that information to you as the design consultant or doing the interpretive analysis. We're not necessarily capturing it for our own in-house analysis. So we need to be working with the industry to grow awareness of what is possible in terms of how it can be captured, and also then refining their workflows to actually be able to extract more value from it than just a traditional ortho photo. So there's been several projects where we deliver this information, but the only way that the client engages with it is those photos in the PDF on the back of the log. Software platforms like Leapfrog and a couple of others in that sort of 3D modeling space could receive this information. So you could have it all in the one place and have it there to be able to review it at the same time as you build your 3D subsurface models. But I think we need more broadly a bit more interaction and innovation. There's a few good companies out there at the moment. Cleario is the name of one. I think they're out of Canada or North America, somewhere up there, where they're building a really good interface to allow people to engage with this technology in the Microsoft HoloLens. So you could be on your side of the country or planet, and I'm on mine, but we can have a virtual meeting where we're collaborating over this same 3D model in the same space. But obviously there's hardware that needs to be purchased, and people won't purchase hardware without a business model, but we can't necessarily develop the business model without playing with it, which sort of verifies how I've come to be where I am with this technology, because I didn't need a business case. I was just being a geek with my son's birthday cake.
That'll probably take up the duration.
Okay, so we've discussed drones and kind of, what we can do with some of the information from that. Is there anything else that can affect what we can do on a day-to-day basis as geotechs in the industry?
Digital technology is touching every aspect of our life in every possible way, right? I think it was Justin Trudeau. I've probably butchered the way his name's pronounced. I think he was the Prime Minister of Canada. In a speech to the World Economic Forum a few years ago, the pace of change has never been this fast, yet it will never be this slow again. So our lives are changing so quickly, but it's the new normal, right? That we need to catch up with ourselves, because stuff's just going to keep on changing, and that's just the way life goes, and I guess that's the way the human race is advancing. So that should be coming across into our daily working lives. I personally don't think I'm seeing huge amounts of change happening in the Australian geotechnical industry at the moment. What we're talking about is the broader topic of digital transformation of business. And so, what is it about banks that have the way we go about our day-to-day banking, personal banking, business banking, is completely different to the way our parents did it. And so what has forced that change and that level of change in that market, but why hasn't our Australian geotech consulting industry changed that much? I really don't think we're very different to what we could achieve. We can't necessarily achieve much more or much quicker than when we were using typewriters to prepare logs. And so there's business reasons for this, like everything else, where we don't go to work every day just to find out how to use new technology because new technology is cool. Like with the test pits, yeah, great, you've built a 3D model of a pit. Where's the value in it? So there's a couple of ways that technology can impact our day-to-day lives. I'm quoting from a fella. His name is George Westerman. I think he's from MIT Sloan Institute. He's one of these businessy types who looks at precisely this question: what is it that drives technology-induced change in whole industries or organisations. And so there's three ways that technology can touch our working lives. And they can be in terms of the internal productivities that we achieve within our own practices or our organisation. So we used to have this workflow that required a few days worth of emailing, getting quotes, getting a surveyor to go out and do something, and then waiting a week for them to produce their report. Whereas now, within 2 hours, we can achieve the same sort of thing just through using a drone. So internal productivity or workflow productivity, the first area. The next one is that we can offer more attractive client experiences. So think about your internet banking and the way you engage with those apps, as I mentioned before, or ATMs even. We don't have to go and wait in line. We don't have to wait, or we can get cash without needing to be able to go to a bank within business hours. So there's a whole lot of client experiences. And another one is the third area that George Westerman talks about is there are whole new products and services, and we can do things that were previously not possible because technology allows us to. So, for example, the photogrammetry with the test bits, right? We started doing those because they were cool, and then we discovered, oh, yep, righto, we can do this orthophoto thing. And one of the more recent things that we've worked out that we can do with these photogrammetry models is as we excavate the pit, we can stop at various points where we detect a layer change, and we can build a model of the excavation as well as the stockpile. We can use these models to then calculate volumes, and so we can get the excavated volume, we can get the bulk volume of the material that has been excavated from the pit, and we can calculate bulking factors just by processing these models, right? So we don't necessarily need to do in situ density tests and have a newt gauge on site and then take material back to the lab to calculate and do all these different things. It's just a byproduct of something that we're already doing. So we can offer new products and services that were not previously possible. So they're the three pillars that George Westerman in particular talks about in terms of how technology can change what we do. We can increase our productivity, offer better client experiences, and produce new products and services. So if we in our geotechnical organisations, be we geotechnical site investigation contractors, I think is what you call them over there, or be us people who receive the data and do analysis and do interpretation or produce the reports or do constructions anywhere along there, if that workflow or pipeline rather, if we can leverage technology's ability to allow our teams and clients to access our information to improve productivity experiences or new products, then we're on that digital transformation path. And it's an exciting time to be there. But for me, the greatest opportunity comes through good geotechnical data management. I think I said earlier, when I was young in my career, or as I developed in my career, I was becoming pretty frustrated with trying to have to do things the old way, where you get a spreadsheet and make 100 copies of it and plug in all the information and make mistakes, or don't know that you've made mistakes until one of the outcomes is really unusual, and then you go back and find out that all 100 of them are wrong and the results are actually completely different. That's always frustrated me, and so I see the greatest opportunity for our future in being good geotechnical data management through a couple of technological platforms which are emerging in the market at the moment, and then that leading through to parametric and generative design that allows us to not only communicate and collaborate over results in real time, but of the site investigation results, in real time, but we can actually have an almost real-time feed of the analytical results and interpretive results coming through in our projects. And that's a big thing in Australia at the moment. There's so much work that the traditional practice of let's commission a site investigation, let it happen, we'll get all the results back, we'll then make those results available for tenderers to go and do their design. What we're finding with many projects at the moment, especially in New South Wales, is we're brought on board at the same time as the designer. And so as quickly as we can produce information, it's being lapped up by the design teams. Time is money. That creates more opportunity. So we're learning how to cater to that.
For the end client, cut project time down?
Oh, look, it's speed, but it's also, again, this is one of those ones where it's an opportunity that they never necessarily had before. If you've got a system that's watching the information that's being produced by your engineer in the field, there's more to just technology enabling this, right? There's entire contractual setups and the way we engage between consultant and design consultant and site investigation consultant needs to change, because you're sharing information very early on before it's been through the rigmarole of necessarily the checking by the experienced geological people on your team. But if you can imagine that we're producing this information before the drill rig's even packed up and moved off that hole, we can have an appreciation, upper bound, lower bound, however you want to manage the sensitivity of this information. But we can have an idea of whether we're going to be able to achieve our predicted outcomes from an engineering perspective. So if we can have that information made available before the drill rig's even packed up, and we go, okay, with all sensibilities, we've looked at this information, it seems legit. Within 2 hours of the last hour or two, we think it's going to be a critical risk to this project. It's unexpected conditions. Before the drill rig's moved on, hey, why don't we just take it forward another 50 meters and put another hole down just to confirm this anomaly that we've seen? It could get worse, it could get better, but we can do that while we're already in the paddock, while the community relation teams are already there and we've got permission to access the land. It's a lot easier to say, hey, we're going to be here for another day, as opposed to the cost of mounting another whole campaign to come back 6 months later, let alone the uncertainty that our designers had to handle in that short term. So that's one of those applications where technology has created this wonderful opportunity, and now we're finding that we can do things that and opportunities on projects that were just not previously possible because of that time delay. So yes, we can do it quicker, but there's a whole range of ways that we can then take advantage of that context.
Okay, so it seems that there's a lot of opportunity for technology to really embrace what is done in many ways. So how do companies go on to adopt this sort of technology?
Yeah, that's the $100 million question, I think. And again, if you look at broader industries, not necessarily geotech, there's been some amazing fails, flops, I guess, from companies who have tried things and it's not worked, or companies who have thought, nah, that'll never take off, and it really has. The pin-up examples in that latter case is the Blockbuster Netflix type example. So there was nothing wrong with Blockbuster necessarily. They had a great business model, but technology changed, and where are they now?
Good example.
It can go both ways, right? You can fail to act, or you can act and have it go nowhere. So I think the key point to start, if you're sitting in a geotechnical consultancy and thinking, gee, there's huge opportunities to improve, one of the best places I think to start is to look at your workflows and look at your objectives. There's plenty of literature out there of an approach called design thinking, and that can work you through both human-centric solutions that are designed for the person who sits in amongst it, but it also looks at it from a problem-first perspective. So understanding what our challenges are. If you're thinking, hey, here's this new technology, let's work out how to use it, I think you're starting in the wrong place. You need to have a challenge and a problem that you're trying to solve. We're not just buying technology for the sake of it. And if in many cases, technology does allow us to solve that problem in a new way and create these sorts of opportunities, but you don't lead with technology.
So for professionals in the field looking to embrace digital transformation, what advice or best practices can you offer to ensure a successful transition?
Look big picture as well. So don't just look at how do I solve this immediate problem that I've got, but think of what is the overall objective of what we are trying to achieve. So an example is with laboratory testing results. I just today actually sent through a file to a client on one of our projects that had over 80,000 lines of results that are specifically for the lab testing. So we've gotten all the lab testing back, collated it together. That's given us 80,000 lines. The traditional way is to potentially get all that, put it in tables, and then export it as a PDF on the back of the report. Update them as they go. But the approach that we take is we've got a central source of truth. We mine all that data from all these different sources into this one central source of truth. And I've provided it to a client as an AGS file, as an Excel file, but I can also do an AGS file. I can produce PDF report summaries from that central point of information. I can from there as well produce ESDAT. I can produce charts and plots and all sorts of things. So rather than just thinking, how do I get my lab results into my tables to go at the back of my report quicker, think, okay, well, what can I actually do with lab results? what are they used for, and can I use technology to make them more accessible? I think that's one of the ways to do it. You were talking as well about professionals. I guess I'd pitch this particular point at leaders in the field. Sequent, the geodata management company, I think they're pitching themselves as these days. Southern Hemisphere, they're headquartered in New Zealand. They recently published a data management survey that they do every 2 years. And one of their questions in particular looked at how digitally mature our organizations. And I like this question because the answers, they looked at it by from the perspective of where people sit in an organization. And they said, how well do you think your organization embraces new technology? People at a company director level, 60% of them, I think it was, said that they were first adopters of technology. Whereas the people at the coalface, the younger generations doing the actual work, only about 20% of them thought the same. And it was a fairly linear trend. The more senior you got, the more you felt that your company was adopting new technology. So there's a big difference, I think, from that perspective at the top looking down versus the people at the bottom looking up who are doing the grunt work. And you're possibly at the top only seeing the output. You're not really in touch with how much effort it took to get there. So I guess one of the other tips would be to speak to people at all levels of your organization, and encourage people to bring those ideas and opportunities and say, what's making your life difficult? What could we be doing better, using the experiences that you've come from as a young person, or someone who's grown up with technology, or seen in other organizations, or things that aren't even of our industry but could be applied here, and look to those sorts of perspectives as well as your own. Seniors, I guess, our people leading our organizations need to adjust their behavior, I think, to work in this context with the juniors. I think is best explained by an analogy that I call the rocket analogy. So if you imagine, SpaceX or NASA or something like this, they send off their rocket, right? As the rocket climbs up to new heights, the smoke trail that's behind them sort of spreads out laterally, right? If you think of the rocket being an analogy of you in your career, as you increase your career, as your career matures and you do more and more years, your rocket gets higher. That trail that you've left behind you, that smoke, represents the breadth of your experiences. So as you spend more and more time going through your career, your breadth of experience, your experience base, so to speak, gets bigger and bigger and bigger. I think the traditional model that our organizations have grown and our juniors have been educated as they come up through our organizations is there's some sort of an expectation that their rocket will always stay centered below your rocket, and their breadth of experience will rarely expand beyond the breadth of experience that's your base, right? So they will always be within your smoke cloud as the organization, as they mature in their career and you progress up to space and retirement. I haven't carried the analogy that far. But I think for the juniors that we're getting through today who are more digitally empowered, because as we've mentioned, the education curriculums are becoming more technology or digital centric as they go. They're coming through empowered, and they already have a base of experience that is outside the footprint of your rocket as it's going up. So you've got, you're sort of running in parallel to each other as you go through your careers. One's not following your shadow, one's off to the side. And so we still need the experience of our mature engineering leaders, but we need the digital capabilities of our junior engineers to be able to achieve some of this opportunity that's in the information. So while the junior needs to veer their rocket, I guess, across from where they are to come closer to your smoke trail, I think what we need to see is something that is unfamiliar for our industry, which is where our seniors actually need to vary their trajectory to come across. And so we need to find collectively as an industry within our organizations some middle ground where our two rockets can sort of come into sync in between, so that you've got the engineering experience and maturity working with the digitally enabled junior. And it's not just senior saying, junior, do it this way. It's senior saying, here's our problem. It's junior saying, we could do this to solve it. And then it's senior saying, let's work on that together, and let's address the engineering uncertainty, the engineering risks, the black box effect, and all these sorts of things in the way that we design this tool together, so that senior has an understanding of how the solution that's come up, that's been built, works. Junior understands the engineering objectives, and together they can come up with robust engineering design. I think that's the way of the future, for other than getting rid of all our senior, our mature engineering talent and bringing up juniors, because they can do it 100 times quicker, is one way. I think a much more sensible way is this way, where our rockets converge together, and we both learn, seniors from juniors and juniors from seniors.
In terms of essential skills that the geotechnical engineers kind of take part in, be part of the digital transformation, what are the essential skills required?
Don't go out and think, I need to learn how to use this specific app. Don't go out and think, I need to learn how to use Python, without first thinking, oh, I need to learn some of the basic algorithmic processes and concepts of how a computer does things. Whether you're writing a script in Python or Visual Basic or all sorts of different proprietary languages that many of the software tools that we use, it's the same concepts that you're using and applying over and over again. So if you can learn to think of them outside of any specific application context, then that's really helpful. The fundamental way of thinking that is being taught in our education curriculums over here in Australia is what they're calling computational thinking. That's the process of breaking down a task, a bigger task, into smaller tasks that can be done systematically. So you take your information, representing your information as data is another key component of that. If you can systematically use data to represent different situations, and then you can understand the different systems, the systematic ways that data might affect a workflow, that's the starting point to sort of appreciate how a computer can take on a task. And that's the starting point to think about, to then go, okay, well, now I could potentially automate this, because I can do these things have to happen every time. So if we can automate 2 or 3 of those, then that's 50% of it automated. And then as your skills in that area sort of develop, you can automate from start to finish and then move on to the next process as well. So yeah, starting with computational thinking, I think if you want something you can plug into Google, that's where I'd start.
Looking back over your career and experience so far, what kind of advice would you give geotechnical engineers?
I think I need to say this carefully. Break the rules is kind of what I want to say. Rules, not in terms of don't go out there and tempt the laws of physics. But I remember off the back of my experiences in West Papua and West Timor, I came back. By the time I'd finished those projects, I was quite a competent user of QGIS and these drone technologies and other things like that. And I took that to the workplace and I thought, yeah, great, this is going to be awesome. And started using it on projects. Up until that point, our test location plans, the map that shows where your boreholes were drilled around a project site, were done with a screenshot in Google Earth and icons in, say, Microsoft Excel or something like that. And I remember getting told, no, you can't use GIS because none of us can use it, and so that interferes with our workflow. So there was an email that was very much a thou shalt not use GIS software. I ignored it, okay. and ended up running GIS training. The company very quickly realized that there was more opportunity in this, and I ended up running training for the entire company to upskill all their engineers into the GIS. But if you think technologies an opportunity is providing opportunity to digitize your workflows, respectfully, I would encourage junior engineers to respectfully keep on pushing those boundaries, to try and work out how you can get it involved in your workplace. There'll be plenty of opposition, but play with the software that you're not supposed to. Learn these systems that have traditionally been the domain of the CAD person or the GIS person. By diversifying your skills, you can really empower yourself and provide huge benefit for your teams, but always do it respectfully and mindfully of your colleagues. There will be a time to not do the GIS thing, to do the old one, because that's the key way to get to your project goals.
So be a respectful rebel.
That's right. A conforming anarchist.
Finally, could you share any kind of future trends or developments that you would anticipate in the ground investigation and engineering sector, and how they might impact the professionals in the field?
I think, again, speaking from the Australian context, I don't know what it's like in the UK. I think your digital community, so to speak, is a lot more established than what we might have over here in Australia. But one of the things that I think we need to do to enable our industry to move forward is increase collaboration. And I think inter-organisational collaboration. I think I've touched on it a couple of times in this conversation, where we've been producing a product and we go to give that to a client and the client doesn't really understand how to use it. And so the value of what we're producing is zero. Hey, here's a 3D test pit model. Great. We don't know how to use it. Just send us a digital still from your camera. Just there's absolutely no value to what we're producing. So what I'm trying to do to help us really capitalize on what we're producing at MacGeo and many other people are doing in their own little silos across the industry, is create a forum where we can come together and talk about what we're doing and talk about the opportunities and the things that stand in the way of the opportunity that can't be solved within a single organisation. So coming back to those test pits, we were recently at a concrete pavements conference where we showed those test pits to multiple state governments owners, asset owners. So they own the highways, and they all said, this is amazing. We could have avoided some significant problems if we had this output on our site investigation. But then they say, so who else can do this? And we say, well, it's only us. We've invested in working out how to do this. And they say, oh, well, there's the problem. We've got no problem with having you there, but we can't write that into a specification because you've got a monopoly on this, on producing this result. And we're like, well, that's kind of the point. That's one of the nice advantages. But from our perspective, maybe what we need to do to allow other people, to allow us to be able to use it more is, to open the floodgates up and train some other people in other organisations on how to do this, so that overall the greater industry can benefit. I've put together a proposal which is in the hands of the Australian Geomechanics Society. There, I presume you'll have a similar sort of organisation over in the UK there as the professional society for geotechs and engineering geologists. But this is to form a digital interest group within the society, where people who have ideas and initiatives like that can discuss them in that sort of a forum. We know who's who in terms of the digital thinkers and the people with skills in this area. And across projects, we can go, hey, this is a challenge, but through the interactions I've had with this interest group, I know that this person of this organisation might be able to help solve it and unlock huge amounts of value across what we're trying to achieve. So technology, I think, is far outstripping our ability to actually use and engage with it productively. So I think the immediate future will be working out how to collaborate and use this technology together.
Excellent. Okay, well, that pretty much brings us to the end of the show. It's been a very interesting one, from humanitarian work to digital transformation. I think in terms of the show notes, perhaps we can put a link to some of the photogrammetry information that you have on the website, and also the NGO. You mentioned a document earlier on. So if you want to just click the show notes, you can have a look on further information in that. But thanks very much for spending the time and divulging lots of information.
Yeah, thanks for having the conversation. Thanks, Michael.
Thanks for listening to this episode of the Ground Investigation Podcast. If you have enjoyed this episode, then please support the show by leaving it a 5-star review wherever you download your podcasts. For more information on what was discussed in this episode, click the link in the show notes now.